In the last class we discussed the properties required by the triangles to be congruent and also minimum requirements or criteria for the congruency. What are the different criteria for the congruency of two triangles? We discussed SAS axiom 7.1 SAS axiom and AAS theorem 7.2. Now we are going to discuss another property of triangles, isosceles triangle. Property of isosceles triangle. Isosceles triangle. What do you understand by an isosceles triangle? A triangle in which any two sides are equal. Such a triangle is called an isosceles triangle. If all the sides of a triangle are equal, then what is it? It is an equilateral triangle. Now, we are going to see the property of an isosceles triangle. This theorem is called isosceles triangle theorem. Theorem 7.2. Isosceles triangle theorem. Isosceles triangle theorem. The property of an isosceles triangle is described as isosceles triangle theorem. Theorem 7.2. 7.2. Theorem 7.2. In a triangle, if two sides are equal, then the angles opposite to them are also equal. If these two sides are equal, then the angles opposite to these two sides are equal. That is, if two sides of a isosceles if two sides of a triangle are equal, then the angles opposite to them are also equal. This is what is theorem 7.2. That is, angles opposite to equal sides of an isosceles triangle are equal. Angles opposite to equal sides of an isosceles triangle are equal. How can we prove this? Consider isosceles triangle ABC. Draw the angle bisector of A. Angle bisector. We want to show that angle B equal to angle C if AB equal to BC, AB equal to AC. AB equal to AC in triangle ABC. In triangle ABC, if AB equal to AC, then show that angle B equal to angle C. To show that angle B equal to prove that angle B equal to angle C, first draw a bisector of angle A in the triangle. Given that AB equal to AC, given AB equal to AC, draw the bisector of angle A. So, the bisector of angle A, suppose this angle is equal to X. Then this also X, because AD is the bisector. Then what is the measure of this angle? 90. This angle also 90. Here, consider two triangles. Triangle ABD. In triangles ABD and triangle ADC. Triangle ADC. Two angles are equal. This and this. 1 and 2. No, two angles of one triangle. 1 and 2. 3 and 4. Consider the angles. In triangle ABD and triangle ADC, triangles ABD, angle 1 equal to angle 2, angle 3 equal to angle 4. Angle 1, because AD is the bisector of angle A. So, angle 1 equal to angle 2. But this is the perpendicular. This bisector will be the perpendicular. That is a property of an isosceles triangle. The bisector of the opposite angle will be a perpendicular bisector of the third side. So angle 3 equal to angle 4. Now AD is the common side. AD equal to AD, common side. Common side and two angles. Which property? Which is the criterion for the congruency? Two ASA. Two angles and included side. Two angles and included side of one triangle are equal to two angles and included side of another. So, what about these two triangles? Therefore, triangle ABD is congruent to triangle ADC. Reason ASA rule criterion. ASA congruency rule. Two angles and included side of one triangle are equal to two angles and included side of another. So by ASA rule we can see that these two triangles are congruent. Then corresponding angles are equal. What are the corresponding angles? This x, this also x. This 90, 90. So third pair, angle B equal to angle C. Corresponding angles are equal. That means in an isosceles triangle, the angles opposite to equal sides are equal. Or in any triangle, the angles opposite in any isosceles triangle, the angles opposite to equal sides are equal. This is what is called the isosceles triangle theorem. Now, can we think of its converse? Let us think of its converse. Isosceles triangle theorem says that the opposite angles of equal sides of an isosceles triangle are equal. Theorem 7.2. The equal sides, the opposite angles of equal sides of an isosceles triangle are equal. That is in triangle ABC with the AB equal to AC. If AB equal to AC, then angle B equal to angle C. It's a converse. In any triangle, if two angles are equal, then the angle and then the side opposite to them are also equal. If sides are equal, then the angles opposite to them are equal. In any triangle, if two angles are equal, then the sides opposite to them are equal. That means if any two angles of a triangle are equal, then it is an isosceles triangle. How can we prove this using the theorem or axiom for congruency of triangles? Same way we can draw altitude. We are given that these two angles are equal. Then what about this? Draw the altitude. AD is the altitude of the triangle. Then 90 degree. These two. Then what about the third side, third angle? This is x. This is also x. Then what will be this measure? 90 minus x. 90 minus x. This right angle 90. So sum of these two 90. These two angles are given. Angle B equal to angle C. And given angle B equal to angle C. Then and here angle 1 and angle 2. We are given in the triangle. We are given angle B equal to angle C. Suppose angle B equal to x, then angle C also x. Then this 90. So what is the measure? Sum of these two in a right angle triangle. Sum of the other angles is 90. So if this is x, then this is 90 minus x. So this. Now, as in the case of the theorem, isosceles triangle theorem, AD is common side. Two angles are equal. So 3 and 4. Here also angle 1 equal to angle 2, angle 3 equal to angle 4. Those of these triangles are congruent. Then the corresponding sides are equal. Which is the corresponding side opposite to the 90? This side. Which is the corresponding side opposite to this 90? This one. So, this since triangle, these two triangles are triangle ABD and triangle ACD are congruent. Angle x equal to angle x. This angle B equal to angle C. So, AB equal to AC. Corresponding parts of congruent triangles. Then what do you understand from this? The converse of isosceles triangle theorem is also true. That can also be proved. This is true. The congruency of triangles. Now we can consider some more conditions, minimum conditions for the two triangles to become congruent. One is suppose we are given two triangles with corresponding sides are equal. Three sides of one are equal to three sides of another. We can see that these two triangles are congruent. And this theorem is called the SSS theorem. SSS theorem. Three sides of one are congruent to three sides of another. SSS. And also for two right triangles. We can establish the congruency of this. In right triangles, one condition is there. One angle 90, right angle. If the hypotenuse of two right triangles are equal, and one side, hypotenuse and one side, any side of two right triangles are congruent, then the triangles are congruent. This result is known as RHS theorem. Here. So, what are the four different conditions for two triangles to be congruent? One, SAS for axiom. SAS axiom. Two, side angle side. Side included angle ABC and PQR. These two sides, suppose these two sides are equal, then which angle? Angle A should be equal to angle B. Included angle. No, not any angle, but included angle. ASA. In two triangles, if two angles, corresponding angles, these two angles and their included sides are equal, then the triangles are congruent. Here what we are checking is only three aspects. To establish whether two triangles are congruent, we must check all the six correspondences. But the minimum conditions are here three. By checking all these three minimum conditions, we can establish by the equality of these, we can see that the triangles are congruent. So we take only three aspects of two triangles to become congruent, to establish the congruence of the triangles. Then third one, SSS theorem. Fourth one, RHS. These are the criteria for the congruency of two triangles. Then property of isosceles triangles. The angles opposite to equal sides of an isosceles triangle are equal, or in any triangle, if two angles are equal, then the sides opposite to them are also equal. Now, for more details, read textbook pages 120 to 128. Then do the examples 4 to 8. Then exercise 7.2, 7.3. Thank you.